So in this video today, guys, I'm going to go over the Mach 2 review, and that test is on Thursday. So this first one says given points G00, H33, and I42 reflect across the x-axis, then reflect across the y-axis. Then it says identify the single transformation that maps GHI to GHI double prime. So I'm going to go ahead and do this first, reflecting across the x-axis. So what is that rule? That is going to be x comma negative y, right? And then when we do our second one, that's going to be the rule. And I'm going to go ahead and put it above here, and we're going to reflect across the y-axis. See, reflect across the y-axis right there. So that one's going to be negative x comma y, right? So let's go ahead and do this to all our g points, and then our h and our I points, and then we'll go from there, okay? So if we do that to g, it doesn't change it at all, right? So that's going to be our g prime. Then our h prime is going to be 3 comma negative 3, because we're just changing the sign of the y. And our I is going to be 4 negative 2, because again, we're just changing the sign of the y. Now the next time, as we do the reflection over the y-axis, this one, we're going to change the sign of the x. So again, g won't change. So it's going to be 0, 0, because it's 0. H double prime is going to be negative 3, negative 3. And I double prime is going to be negative 4, negative 2. So let's just take one of these and compare it and come up with one, because it says identify the single transformation. Identify the single transformation, okay? So if we just take 4, 2, and we look at what it is here, negative 4, negative 2, what happened? Both of them became negative, right? So it's negative x, negative y. So what single transformation is that? That is a 180-degree rotation, right? So that's what this problem is asking, okay? So number 2 says, given the figure DEF, after a transformation, the points of the figure become D prime, blah, blah, blah. Identify the transformation. So let's just compare again. I don't want to use the one that has the zeros. I don't want to use the one that has the same points, but I want to use one that has 2 unique points. So I'm going to use F and F prime, okay? So I'm going to do F is 1, negative 4, and F prime is going to be 4, 1. So what is the first thing you guys notice happened? They switched, yep. So this is going to be Y, X. Now which one changed signs? The Y changed signs, right? So, and it became positive, right? So we're going to put the negative in front of there. So what is that? So let's look at our thing here. So this is y, x, right, where this is negative, okay? So that is what? 90 degrees counterclockwise, or what is it clockwise? Isn't that going to be 270 degrees clockwise? Okay, so we don't have 90 up there, C as an answer, so this is going to be our answer right there, okay? All right, so given the image coordinates of ABC prime, identify the pre-image of coordinates ABC from a reflection over y equals x line, and then translating. So in this, what you guys need to think of here is that we're going to move backwards, okay? So that means we're going to start with this. We're going to do this first, okay? And then we're going to do this second. So we're moving the opposite direction, because what we want to find is A, B, and C. Where do we start? So it says given the image, identify the pre-image. Key words right there, okay? So the other thing that you guys need to notice is we need to do the opposite of what's there when we have a translation coordinates. We're going to do the opposite. So we're going to actually do x minus 2 and y plus 3. So we're going to create an A prime. So we're going to do negative 3 minus 2, so that would be negative 5. Then we're going to do 5 plus 3, so that's going to be 8. We're going to do that with b as well. B prime would be negative 1 again, minus 2. So that would be negative 3, and we were going to do 1 plus 3, so that's 4. And then we're going to do C prime, minus 4 again, minus 2. This is going to be negative 6, and 4 plus 3 is going to be 7. Now, we already said that the next thing we're going to do is this, right? The reflection over the line y equals x. So that means we're going to swap y and x, right? They're going to switch places. So our A is going to be 8, negative 5. Our B is going to be 4, negative 3. And our C is going to be 7, negative 6. Okay, and if you want to double check them, take them forward through that and make sure you got your ABC double prime. Okay, so number 4 says find the preimage of E double prime 9, negative 7. If the vector transformation with a rotation of 270 degrees, then a translation with a vector of negative 2, 5. So on this one, again, we're going to make this a plus 2 and a minus 5. Okay, and that's what we're going to do first because it's what we originally did second. Now, I need you to think about this right here. A 270 degree rotation is counterclockwise, right? So if we want to do the opposite, this is going to be a clockwise rotation, right? Because it was counterclockwise, okay? So what is the, that's also equal to what? A 90 degree clockwise rotation, or a counterclockwise rotation, sorry. So that rule is going to be negative y comma x, okay? So here again, we're going to do this first, right here. We're going to do this process first, and then we're going to do this one, okay? So this is going to be what we're going to do second. So let's just look at our 9, negative 7. So here again, we're going to add 2. So we're going to add 2 there, and we're going to subtract 5 there. So that's going to give us for our E prime 11, negative 12, right? Then we're going to apply this rule to it because we're going the opposite direction, right? So that's going to give us, we're going to flip them first, negative 12, comma 11. And remember, we're going to change the sign of that. So that's going to be a positive 12, 11. So that's why this point is C. All right, this says identify the transformation in the following images along with their rules. So again, if you remember, and ignore the double prime because it shouldn't be there, it should just be prime. So we're going from P to P prime, R to R prime, Q to Q prime, right? So note, wow, I couldn't draw that straight, could I? Sorry, y'all. They're going to overlap each other anyway. So if you recall, we want to look at these lines and make some determinations. So hopefully you guys can see that they're parallel, right? So but they are not the same length. So what we want to do is bisect these lines. So that would be a bisection of P to P prime. This would be a bisection of R to R prime and Q to Q prime. So that's where my line of reflection is going to be. So this is a reflection over what? Over the y-axis, okay? All right, so this next one. This time we're going to connect our vertices again. So we're going to do L to L prime right there. We're going to do M to M prime right there. We're going to do N to N prime. Ooh, they just crossed. So if you notice that, because they crossed, we know this is a what? We know this is a rotation, right? So now we want to figure out how far did it rotate. So remember, we always go counterclockwise, the order of the quadrants. This is 1, 2, 3, and 4. So let's figure out how far we went. We went from this quadrant up to there. So how many quadrants did we just go? 3 of them, right? So that's going to be 270 degrees. That's a normal rotation, right? And if we do a clockwise rotation, it would have been 90 degrees clockwise, right? All right, so now let's do our last one. We're going to go from C to C prime, A to A prime, B to B prime. Those are all 3 parallel lines, and they are the same length. So this is a translation, right? And it looks like a 3D image. Okay, so this is a translation. So let's now count from one of these points. So let's count from C to C prime. So this is 1, 2, 3, 4, 5, 6. So 6 left. And 1, 2 up. 2 up. So if we were to write that as a vector, it would be -6, 2, right? And if we were to write it as coordinates, it would be x minus 6, y plus 2. Okay? All right, so the next one says what point P is reflected over line y equals 3. So we're going to go ahead and plot this point P, which is -1, -3 right there. So that's my original P. And then we have this line y equals 3, which is a horizontal line where y equals 3. So, oops, that's going to be up here, y'all. Wow, I cannot draw a straight line for nothing today. So let me show you if I can do this again. I'm just going to do it dashed. Maybe then I can make it a little straighter, y'all. So there's my line through y equals 3. And let's count how far away that is from let's count this P. So it's 1, 2, 3, 4, 5, 6. So 6 below. So to reflect over that line, we want to go 6 above, right? So 1, 2, 3, 4, 5, 6. So that's where my new P, my P prime is going to be. And so isn't that at negative 1, 9? It is. So that's P prime. Okay? All right, so this says identify the number of lines of symmetry and the degree of rotation for the following regular polygon. So if this is a regular polygon, it's got 9 points, right? 1, 2, I'm going to count 3, 4, 5, 6, 7, 8, 9. And this could be irregular, right? So on this one, we're going to divide 360 by 9, and that's going to give me 40 degrees, right? So that's why the answer is C. So this is which of the following statements is true about the figure? Select all that apply. So let's look at this. If I were to add D to B, would that be equal to 180? There's no reason I could say that, so let's say that's not true. Okay, then if we look at the next one, which is C plus D, that one right there, C plus D, C plus D, that would be these two angles, right? Do they equal D plus C? Whoa, I did that wrong, y'all. Let me go back. Sorry, the first one is C plus B. C plus B is right there. That's those two angles. Y'all see that? They form a straight line, right? And then we have D plus C. D plus C also form a straight line, don't they, right there? So yes, they would be equal because this is equal to 180 and this is equal to 180. So that is true. Then it says reflect across the line CE. That would be this line right here. CE is right there. Okay. Then angle CBD. Where's CBD? CBD. That's this angle down here. Is the image of EBA. EBA. EBA is right there. So if we reflect them over one another, so that to me looks like if I was going to reflect it, I'd have to reflect it there, right? So wait, let's look at these points. Let's look at the points just to verify. So CB, so C is going to turn into E, right? And B is B, so we got that one. That's right there. So we got that one good. And then A becomes D, right? So is that a reflection over that line? If we were reflecting over that line, y'all, then the angle would have to be up here. This red angle would have to go up there. So that is definitely not true. Rotate 180 degrees. So if I was to rotate 180 degrees, let's just do this again and give these different colors. So if we were going to go CBD, so CBD becomes E. Yes, if we rotated that 180 degrees, definitely that would occur. Y'all see the difference here? So that's D and that's A. So that was definitely true. And then reflect across the angle bisector of ABC. ABC, yeah, that's what I was talking about before. So this is that angle bisector right there. Yes, that would be true as well. So all of these are true. So it would be B, D, and E, okay? And I don't think that's what was on the key. I think I had C on there, y'all. So it's definitely not C, okay? So, not C. Not C. Okay. So, number 8. Let's go on to number 8. Solve for x and y. So notice here that when we solve for x and y, so if we solve for x, that is a linear pair, so we can add these together and set them equal to 180, right? Same way over here, add those together, set them equal to 180. So that's what we're going to do. So we're going to do 2x plus 10 plus 4x plus 20, and that equals 180. So that's going to give us 6x plus 30 equals 180. We're going to subtract 30 from both sides. That's going to give us 6x equals 150. So x is equal to 25 here. And then we're going to do our y's, okay? So now we're going to do 5y minus 25 plus 2y plus 2. That's also equal to 180 because they form a line. 5y plus 2y is 7y. Negative 25 plus 2 would be negative 23 equals 180. We're going to subtract 23 from both sides. No, we're going to add 23 to both sides. Sorry about that, y'all. Because remember, we'll add 23 here, add 23 there. So that's going to be 7y is equal to 203. We're going to divide both sides by 7. So y is going to be equal to 29 here. So there's your answers for x and y. Number 9 says, for each example, find the indicated angle measure, then state the angle theorem used. So it's asking us to find BEF. So BEF is that angle right there. Okay, so we need to talk about what is the relationship between the two angles we're given. So can you guys see that this angle is congruent with that angle? Because they are corresponding angles. Okay, so that's why they are congruent. So that means we're going to set them equal to each other, right? Okay, so let me extend this page down here so I can do a little math. So we're going to say 7x minus 14 is equal to 4x plus 19, right? Subtract the 4x from both sides. So that gives me 3x over here, and that's now gone from there. We're going to add 14 to both sides. So that's now gone from there, and that's equal to, what is that, 33? We're going to divide both sides by 3. So x is equal to 11. Okay? That is not the answer. We must plug that back up into this equation right there. So we're trying to find the measure of angle BEF, right? So to do that, we are going to do 4 times 11. That's 44 plus 19. So that's going to be equal to 63 degrees, right? And on y'all's paper, there were answers, and I guess I didn't put them over here. That was answer B. Okay, y'all? All right, so for this next one, it's asking us to find the measure of angle EBC. So EBC is this angle right here, okay? So now what is the relationship between those two angles? They are same side interior angles, right? Which means what, y'all? They're supplementary, right? So I'm going to write that too. And that means they add up to be 180 degrees, okay? So when I add these two together, I'm going to set them equal to 180, okay? So when I do that, 6x plus 3x is 9x plus 9 equals 180. Subtract 9 from both sides, so 9x equals 171, and divide both sides by 9, and I get that x equals 19. Again, that's not the answer, because we are looking for this angle right here, okay? So we must do the measure of angle EBC is equal to 3 times 19 plus 9. 3 times 19 plus 9 is equal to 66 degrees. Okay, for this next one, it says, which pair of angles in the diagram must be congruent? Okay, now it does not show us that the lines are parallel, so we cannot assume that. So let's look at angle 1 and 5. 1 and 5. Now, if the lines were parallel, we could say that is true, but we don't know that they are congruent because we don't know if those lines are parallel, so we can't say that one. 3 and 4, obviously not, because the only way we would know that is if they were both right angles, okay, because those are a linear pair. What about 5 and 8? 5 and 8, y'all. Oh, yes, because they are vertical angles, right? And then obviously D is not true. Okay, vertical angles will always be congruent. The next one says 2 parallel lines were cut by a transversal. Which of the following scenarios is not a possible result? Okay, so 2 parallel lines were cut by a transversal. Okay, these are parallel. Okay, it says a pair of same side interior, that would be this and this. With angle measures of 65 and 115, that's 180, and that would be true, right? Because they're not the same shape. That means they're supplementary, right? So it's saying which of the following is not true, so that is definitely not the answer. A pair of alternate exterior angles would measure 130 and 50. So alternate exterior, that would be here and there. Well, that's definitely not true because they both should be what? These should be equal, right? So that is our answer right there. Let's just double check the rest. Linear pair means a pair of angles that are what? Next to each other like that, form a line. Those would be supplementary, so that's not true. A pair of corresponding angles with a measure of 40 and 40. Again, if we had corresponding angles, that would be like this angle right here and this angle right here, and those should be equal, right? Okay. So this next one says, which of the following reasons should be used to correctly complete the proof? Select all that apply. In the figure shown, line CF intersects lines AD and EH at points B and F respectively. So it says that we're given the first piece of information. So then it's saying CBD right there is congruent with ABF. So where's ABF? So ABF is right there. So we're talking about these two angles. Why are they congruent? Because they're vertical angles, right? So it's E. So E is the answer there. And then why would we be able to say the last step, ABF is congruent with BFE? So notice here, we have 1, 2, 3 different angles, don't we? So wouldn't that be the congruence of angles transitive? Congruence of angles is transitive, so this is B. So B would be your other answer, okay? All right, this one says use the information to answer questions 13 and 14. Aisha wants to prove that the measures of 3 angles in a triangle are always have a sum of 180 degrees. She decides to prove this conjecture using rigid motion. She began with triangle ABC shown in figure 1. So this says, which statement best describes the rigid motion she used in figure 2 to support her proof? It says reflect triangle ABC across AB, so there's AB, and across AC. So I don't see, yeah, this is definitely, that's not a reflection of this, y'all. Okay. And this is definitely not a reflection either. So that's definitely not true. Okay, so I'm going to erase that so we can keep working through it. Then it says rotate triangle ABC 180 degrees about the midpoint of AB. So that means we would be rotating about that point. So that would move this point to there. Yep, that would be true of that one. So let's see if that's true for the other one. And about midpoint AC. So here again, if we rotate it all the way around, this side right here would end up there. So that is true. So that must be our answer, but let's check the other two. Translate triangle ABC along directed line segment AD. So here's directed line segment AD. Yeah, that's definitely not true. Reflect triangle ABC across AB. Reflect triangle ABC across AB. Then translate. Yeah, that's not going to get us both of them, so that's not true either, okay? So our answer was B, okay? How does Aisha diagram prove that triangle angles ABC equal 180 degrees? Well, that's because if we look at these 3 angles right here, y'all, what do they form? So if I do the measure of angle A plus the measure of angle B plus the measure of angle C, don't they equal 180 degrees? Why? Because they form a line, right? And they're supplementary. That's what that means, right? They are supplementary. All 3 of them add up to be 180 degrees, right? That's why. Okay? Supplementary. Sorry. All right. So it says use the following triangles to solve for the missing angle. So we're looking for the measure of CAB. So we add all 3 of these together, and what should they equal? 180, right? So we're going to add 7x minus 1 plus 7x plus 8 plus 5x plus 2. And we're going to set that equal to 180. So 7 plus 7 is 14, plus another 5 is 19. So that's 19x. And minus 1 plus 7 plus 8 is 7. 7 plus 2 is 9. So that's plus 9 is equal to 180. So that's going to be 19x. When I subtract 9 from both sides, 171. So x here is equal to 9. So then I'm going to plug that 9 back in, and we're going to solve for angle CAB. So CAB is this angle up here. That's the one we're talking about. That's our question mark. So we're going to do 7 times 9 plus 8. 7 times 9 plus 8 is equal to 71 degrees. So that was the angle that we were trying to find. That's equal to 71 degrees, okay? The next one is a right triangle, right? So these two, now there's two ways we could do this, y'all. We could do 90 plus 3x plus 1 plus 2x plus 4 equals 180, okay? Or we could just know that these two add up to be 90 because we already used 90 right there, right? So we could say also 3x plus 1 plus 2x plus 4. The second step would be pretty much the same, y'all, is equal to 90. Because if we subtracted 90 from both sides, that's what we would get. So we get 5x plus 5 is equal to 90. Subtract 5 from both sides, so 5x is equal to 85. Divide both sides by 5, so x is equal to 17, right? Now, again, that's not our answer, right? That's not our answer, y'all. We got to plug the 17 back in because it's asking us for the measure of angle ABC. So the measure of A, B, C, that's the question mark right there. That's the one that we want to find. So we're going to multiply 2 times 17, that's 34, plus 4, that's 38 degrees, okay? So that was why the answer was B. Now this next one says the acute angles in a right triangle, WXY, are congruent. So it says we have a right triangle, right? And it says the acute triangles are congruent, right? So if this is 90 degrees, what do we have left? So couldn't we do 180 minus 90? That's going to give me 90. And it says these are congruent, right? So that means we're going to divide that by 2. So both of those angles are going to be 45 degrees, right? Y'all got me? Okay. All right, use the diagram to answer 17 through 21. Describe the relationship between the angles A, B, and C. So we're talking about the angles inside the triangle. So don't we go measure of angle A plus the measure of angle B plus the measure of angle C equals 180, right? Then it says, for number 18, describe the relationship between F, B, and A. So this is F out here, and this is B and A. So you're going to add those together, and they equal that exterior angle, right? So the measure of angle F is equal to the measure of angle A plus the measure of angle B, right? Okay. So now it says if the measure of B is 85, we're going to put that right there, 85 degrees, find the measure of angle D. So these two angles form a linear pair, so aren't we going to go 180 minus 85? That's going to be equal to 95 degrees. And that's because they are a linear pair. And we could say they're supplementary too, right? Sorry. All right, using the information from 19, find the measure of angle C if the measure of E is 115. So it says E is 115 out here, right? So now don't these two angles added together have to equal that exterior angle? So 115 is going to be equal to 85 plus C. So we're going to subtract 85 from both sides. So the measure of angle C is going to be equal to 30 degrees, right? Okay. So now I'm going to put that 30 degrees up there so that we have it. Let me see. So what else do we have? We have 95 as well, don't we? So the measure of angle D was 95 degrees. So let's put that out there, 95 degrees, okay? And then we have now C, which is 30 degrees, okay? Then it says, using the information from 19 and 20, find the measure of angle A. So hopefully you can see that the three of these form 2 of 3 angles inside the triangle, right? So we're going to add 85 plus 30. That's going to give me 115, I think, right? Yeah, 115, and we're going to subtract that from 180, right? So the measure of that third angle is 65 degrees, right? So that's 65 degrees right there, okay? Now we also could have subtracted what? We could have subtracted the 115 from 180. Y'all see this right here? Let me show you. Right there's 180 degrees, right? So to find that angle, we could have also done 180 minus 115, which would have given us 65 as well. Either way would have worked. All right, so 22 says, using the following triangle, solve for the missing angle measure, okay? So here again, these two angles added together equal this exterior angle. So that's what we're going to do. So we're going to do x plus 25 plus x plus 17 and set that equal to our 3x plus 2, okay? So that's going to give us 2x plus 42 equals 3x plus 2. So I'm going to subtract the 2x from both sides. So now the 2x is gone, and we're left with x over here, and then I'm going to subtract 2 from both sides. So that's gone from now, and so that gives me 40. So x equals 40. So now it's asking me for BAC. So BAC, remember that little middle letter is always going to be what we're looking for. So that's going to be x plus 25, which means we're going to do 40 plus 25, and so that angle measure is going to be 65 degrees. So that's C. Okay, so now we did this problem in our warm-up. So what we want to do is, what you should see first is that these two angles down here, this angle and this angle, are congruent. Y'all got me? And the reason they are congruent is because those sides are congruent, okay? So they're called base angles, and they are congruent. So what we're going to do first is we're going to subtract this top angle from 180, and that's going to get us 108, right? And then because these two angles are congruent, we're going to divide that 108 by 2, so that's going to give us 54 degrees, right? So that means that both of these angles down here are 54 degrees. This is 54 degrees, and this is 54 degrees. So now we could solve x one of two ways. We could add these two together, 54 plus 72, or we could do what? Do you notice right here, we got another line, right? So couldn't we do 180 minus 54? So both of those are going to give you the same answer, which is 126. So this is 126 degrees, so is this, okay? It doesn't matter, again, which way y'all do it, okay? But that's the angle measure, 126 degrees. All right, number 23 says, in triangle ABC and DEF, the measure of A and D are congruent. The measure of B and E are congruent. Find the measure of F if an exterior angle A measures 107 degrees, B is blah, 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 and C is. So let's just go ahead and draw this. So we've got triangle. Well, let me do that again. Triangle A, B, C. And then we've got another triangle over here, D, E, F. It tells us in this that A is congruent with D, right? That B is congruent with E. And then it tells us find F if an exterior angle at A, B, C, okay. If an exterior angle at A measures 107 degrees. So if this is 107 here, then we could find that interior angle, right, by doing 180 minus 107. That would be equal to 73 degrees, right? So this angle right here is 73, which means that angle right there is 73, okay? Then it tells us that measure angle B and C, measure of angle B and C. So a measure of angle B up here, it says is 5x plus 2. The measure of angle C right there is 5x plus 5. So again, do y'all notice we have three angles? 1, 2, 3. We can add them together, set them equal to 180, right? So that's what we're going to do. 5x plus 2 plus 5x plus 5 plus 73. That equals 180, okay? So that's going to be 10x, and then that's 7. That's going to be 80, right? 80 equals 180. Subtract 80 from both sides, so 10x equals 100. So x equals 10, okay? So then it's asking us to find which measure? Find the measure of f, right? Y'all see this right here? Find the measure of f. Right there. That's what it's asking us. I'm pushing that button. It's not pushing. There's f, okay? That's what it wants us to find, is this angle right here. Y'all got me? This one right there, okay? That's the one we're supposed to find. So that means if we find C, 1, 2, 3, it's going to be congruent with what? Actually, let's do it like this. 1, 1, 2, 3 arcs there is equal to with this one, 1, 2, 3, right? So if we find C, we find F, right? So let's do C. So that's going to be 5 times 10 plus 5. Isn't that going to be 55 degrees? It is. So that is the measure of F, 55 degrees. All right. Number 24 says, use the following images, solve for the missing angle measure. So this time we're finding angle C. So notice we have one arc, right? So these are congruent. This would be 83 degrees, right? And then we have 42 degrees over here, 2 arcs. So this would be 42 degrees over here. So we're looking for C. That's this angle right here, right? So aren't we going to add 42 plus 83? Find what that is. That's going to be 125, right? And we're going to subtract that from 180. And that's going to give us, if I'm not mistaken, 55 degrees, right? That's our answer. All right, so this last one. Oh, wow, this looks really familiar. We did this one already, y'all, in the warm-up. So this is 55 degrees. This is 62 degrees, right? So again, now notice we have 2 of 3 angles over here, right? So if we're trying to find R, then wouldn't we just add those 2 together and subtract them from 180? So we're going to add 55 plus 62. That is 137. Right? No, 117. Sorry, 117. Trying to do that in my head, y'all. 117. We subtract that from 180. So that is going to be 63 degrees. Okay?